Every year, up to 3 million tons of microplastic enter our water ecosystem via various sources. It's a silent crisis found in our rivers, our ocean, and even our own bodies. But the core problem isn't just the pollution, it's a state of data blindness. Current monitoring relies on slow manual sampling or industrial equipment that costs over $50,000 and is stuck in a lab. We need a solution that is fast, affordable, and works right here in the water. Introducing our solution, an autonomous robotic system designed for real-time in-situ microplastic detection.
How do we see the invisible? The secret lies in our optical system. Unlike standard cameras that see colors, our system sees structure. The method begins with a laser source that is used to create circularly polarized light. And we use a laser source that is placed at the focal point of a convex lens combined with a linear polarizer, a quarter wave plate, to create the circularly polarized light, and the sample chamber to pump water through, and the polarization cameras. As the beam travels through the water channel, it encounters microplastic. Here lies the fundamental physics. While water and other impurities such as dust is optically isotropic, plastic exhibit birefringence. Consequently, the particles induce a phase retardance and alter the polarization state of the cameras, whereas the medium and other contaminants do not. To capture this interaction, a polarization sensor is used to record 4 digital holograms simultaneously at 0 degrees, 45 degrees, 90 degrees, and 135 degrees. We apply the stack standard deviation, or SSD for short, algorithm to isolate the particles from the water. For every single pixel, we take the stack of 4 intensity value and calculate the statistically deviation from the mean light intensity using this equation. Physically, for isotropic materials such as water and dust or grass, these 4 values are nearly identical, so the result is 0. For birefringent plastic, the values fluctuate widely, yielding a high SSD value, effectively functioning as a high contrast background removal filter.
To bring this physics into the real world, we engineered a persistent optical module. At its core is a previously mentioned optical system, fed by the water pump and the fluorescent sensors, enabling continuously fed water through the sample chamber, ensuring stable measurement. It's processed locally on board using an NVIDIA Jetson NAND. This approach runs our algorithm in real time, enabling on-site detection and mapping of microplastic readily, eliminating delays associated with laboratory analysis. Navigation and motion control are handled by a Pixel flight controller and a Raspberry Pi, which coordinate propulsion and mission execution through multiple electronic speed controller, which power air thruster. Power is supplied by a compact LiPo battery system. Together, this integrated hardware architecture enables direct microplastic data analysis and portable deployment in aquatic environments.
Hardware captures the data, but our software makes them actionable. First, we compared machine learning algorithms like SVM and KNN. The results were very conclusive. KNN significantly outperformed SVM. We evaluated multiple versions of JOLO. Using MAP 50 and MAP 5095 as the metrics for our strength, we determined that JOLO version 5011 as the clear winner. If we translate the complex data into a visual and live density heat map, instead of just showing the raw numbers, the users will be able to see an intuitive visualization of pollution hotspots in real time. This allows for immediate decision making, turning invisible data to visible action.
We target the environmental NGOs and university labs. The institution urgently requires scientific data integrity, but lack the budget for industrial equipment. To unlock this sector, we adopt a hardware-enabled software as a service strategies. We retail the robot at $6,000, undercutting legacy competitors by over 70%. This creates a healthy 36% gross margin compared to the $3,850 cost of goods. For long-term sustainability, we offer a software subscription at just about $20 per month. This creates a recurring revenue stream to fuel our future growth.